All right, so welcome. Like I said, I'm Jonathan Dearborn, game programming. I've done a bunch of independent game development in my experience. I've also worked with companies like Disruptor Beam and a contractor, Tricky Fast. I've worked on Disruptor Beam's Star Trek Timelines game, which was really fun. Has anybody played it? Probably not. All right. Well, it's good. It's really good. Should check it out. All right, so I'm assuming that you have some understanding of C#, right? We good with that? And that you have downloaded and installed Unity. When you launch Unity, it opens up with the Unity Hub, and here you can manage like your installations and the different projects you have. So you can go into new and choose which version. I have multiple versions here. I'll just go with the latest that you're going to create your project for. So follow along, try to do what I do roughly, but I'm going to go fast. I'm going to assume a lot of things. I kind of have to if I want to get the most to you in this amount of time. And just hold on, don't get bogged down, just keep going with it, and we can have, I can answer questions as we go too. If you ever have a question, just raise your hand. So I can't cover everything, of course, so use this as a kind of springboard to using other resources that you can find out there. Tons of resources online for Unity development. All right, so I'm going to make a new Unity project just to get going. Let's say Crash Course sounds great. I'm also going to have to find a good spot for this project to live. And this is important for developers such as yourselves. I can't just choose any location. What I should do really is choose a location that's under version control. Are you guys familiar with any sort of version control at all yet at this point?
GitHub,
Okay.
guys.
Git?
Doing GitHub,
Maybe.
that's version control.
All right, yeah. So Git is a really good example. I'll run through just an example using, right now I'm using for my own personal stuff and some of my school stuff, GitLab. It works just like GitHub. So if you've used GitHub before, it's going to be very familiar. But most of these websites, they give you a place to host your projects, so you can have a repository that you continually interact with in order to save your progress and make changes and roll back changes and all of that. So, yeah. This part, for some reason, is longer for me.
So while you're waiting, I can ask, what made you choose GitLab versus GitHub?
So GitLab has, I think it has better support for multiple users on the same project that is also a private project that you don't want to pay for. So it's freer in that way.
So under that pressure,
There
GitHub
we go.
opened their private to be free. They didn't used to be, but yes.
Yeah. So anyway, yeah, let's make a new project here and go with that. Yeah, that's all good. And I'll make this public. So when I do commit to this repository, I'll be able to share this with your instructor, and you can pull the entire project that I create from this. So I'll just clone this to my my thing here. All right. So if all of those seem like quick steps, it's because I'm used to doing this. All right, so here's the folder where it's going to be, and I'll share that link at the end of the lesson. All right, so having that, I should then use that directory for my project. Where is it? Here it is. And then I can create it. Okay, so while that's creating the project, that'll take a minute or two. Another thing just to set up the Git repository, I'm sure you love the link thing. My son did that to me. So I just left it. If you look for something like git ignore Unity, a git ignore file is going to help us avoid committing and uploading and downloading and all that stuff, files that really are meaningless or even less than meaningless. So this is a file that will tell Git which kinds of files that it should just completely ignore when you're committing to your repository. So I'm going to grab this file. This is a fine way to do it. Go to my new repository or working directory here, and in the actual project folder that Unity's been creating, I'll throw this .gitignore file in there. And it has to be named exactly .gitignore without anything else. All right, we'll see how Unity's doing. Still copying stuff. So this may take a little bit. I feel like an older version of Unity was doing it faster for me, but we'll have to be patient with it.
Can you maybe tell us a little bit about background of Unity while we're waiting for this to
Sure.
happen?
So one of the big core parts of understanding Unity is that it works in a 3D space, and in that 3D space you populate it with game objects. Game objects are kind of the big thing. And each game object acts as a kind of container for behaviors. You can think of game objects as like enemies or walls or your player character, or even like an object that manages the game state, like records the score and all that stuff. It can be anything. It can do anything. And they're scriptable. The way that you populate game objects with behaviors is to give them components. And so there are those two big things, game objects and their components. And it's the game objects act as kind of like an empty generic container for components which give the game object its behaviors. And so C# scripts are one kind of component that you can attach to a game object and give it whatever behavior you want. There are a lot of built-in components that give you like more access to the different parts of Unity and the game engine. Like there's a transform component that's built into every game object that gives you like X, Y, and Z, position, rotation, and scaling, kind of the basics. Then there are other components such as rigid body component that gives an object the ability to move on its own if it's like given a force or a push. And a helpful component along with that one is a collider component, so that you can set the bounds of a collision volume, so that the object can bounce around with things or get knocked over. All right, so it looks like we're here. So let's just take a tour over all the different panels that appear up here. Give you a sense of what this editor layout looks like. This is the default layout. If you mess things up, because you could like drag things around and get very confused, there are in window layouts, you can go back to the default layout and it should fix everything. All right, so starting from the middle, we have the main scene view. Here you can see on this tab, it's labeled as the scene view, and it kind of, by default, swaps between the scene view and the game view. In fact, if you press play up here, it will make sure everything's ready to play, and it'll switch over to the game view in order to show you what your game actually looks like when you're playing it. But even during that process, while it's running, you can switch back to the scene view and explore what's going on in your game. All right, so a big thing as we go forward, make sure that playback is stopped completely before you make changes, because a lot of those changes will end up being temporary just during that game run, and they'll be reverted. So if you like move an object to the perfect position you wanted it to be in, and then stop playback, it'll go back to where it was. can be kind of annoying. All right, so in the main scene view, you can navigate by right-click is one of them. You can right-click and hold, and it shows me an eye with like a little cross keys. Can you guess what keys those are? On the icon? No guesses? All right. So W, A, S, and D will let you kind of navigate around in this space. So that's one way you can get around. If you middle click drag, you can pan the camera as well. And if you alt and left click, you can orbit the camera, just to give you a way of moving around a 3D space, right? Scroll wheel will zoom, and that's pretty standard. All right, are we feeling good? Any questions so far? All right. So, there are a bunch of different features of the scene panel that you can check out. There are different tools here. I've been using the move tool, which is one that you can use to select objects and move them around. In our scene to start with, we have two objects. There's a camera and there's a directional light, which is a light source like the sun. And we can also like choose these things and choose some of these other tools and mess around with them, right? Change their facing or their location. There's also a scaling tool and then a couple of other tools. One of these we'll talk about later for working with user interface. All right, so navigating that is important to understand. You'll also notice in the upper right corner, there's a widget that, or a gizmo thing that shows you the coordinate system for Unity. Anything you notice that's worth noticing or pointing out about this coordinate system? Is this the one that you use in a math class? Be brave. What do you see that's important to point out about this? Yeah. Is X, Y, and Z. Yep. What's particular about this one? It's not a trick, but it's a detail. All right, so the y-axis is pointing upward. That may not be what you're used to in a math class. Very often in a math class, you have z pointing upward, right? So when we're working with our scripting, we just have to keep that in mind. Y is up, big deal. It also, if you go further in math classes or physics classes, you'll recognize that this is actually a left-handed coordinate system. It's another detail, but your math might care. All right, cool. So let's move around to the hierarchy panel. The hierarchy is just a textual list of all of the objects in the scene. This is hierarchically organized. So you can have objects that have sub-objects or child objects attached to them. And when the parent object moves, all of the sub-objects move with it. So let's go and create some objects. There's so many ways to do this. If you right-click in here, this is my favorite way, right-click in the hierarchy panel, you can go down to this list under where it says Create Empty. There are options for other objects to create. And so if you feel like browsing around and messing with stuff, this is a great place to start. You can see a lot of the junk that you can create with this. So let me create first a 3D object, a plane. Cool. And it'll give you a chance to rename it if you care. You can call it like the ground or something. Let's also create another 3D object. And do you guys want a cube or a sphere? Which one's more fun? Cubes? All right, they're pointy. All right, there's our cube. And we can even rename this. Let's call this the player. All right. And so you can see now when I have these selected, they have these handles on them so you can move them around in the 3D scene view. If you look really close, like this thing started off embedded in there because its center point is in the middle. But you can raise it up or you can just look at the numbers and try to make it lay on the surface of the plane. An important thing is that sometimes when you create objects here, they don't start off at the coordinates that you expect them to. It depends on where your view currently is. So if I want to zero all these out, I can set all the position values to 0 over here in this other panel. And then I can take the player object and do the same. And that brings my, my stuff all to the center of this coordinate system. All right, so while we're over here, this is the inspector panel. The inspector panel, you do a lot of work in the inspector panel. When you have a game object selected, the inspector panel updates to show you what the game object is and what components it has attached to it. And you can see right off the bat that all of these game objects have that transform component. Every one of them has a spatial position in 3D space. It has a rotation and a scale. And so we can adjust all of those to our liking. You can see also that these objects that we're going to be working with a lot, the plane and the player, they have some additional properties to them. So this cube, the player, has a mesh filter component, which is really just a reference to a 3D mesh that is going to be used for rendering and such. A mesh renderer component that relies on that mesh in order to draw what's going on here on the screen. And then a box collider that's going to be used for the physics system. So now that I know a little bit about these, I can probably position this better. If I position it up here, you can see that I'm kind of getting close to 0.5. So you might be able to guess what the dimensions of this cube are. If I have to move up 0.5, this is a 1 by 1 cube, or a 1 by 1 by 1 cube. The units in Unity are pretty much arbitrary. You could assign any meaning you want to these units, like 1 unit to the left. What does that mean? But we usually say that it's meters, so roughly 3 feet. So if you just remember that, it also gives you a sense of the scale of your game. If you have a humanoid character, they're roughly 2 meters tall. And so everything in your game should be proportioned around that. Okay. So down at the bottom of the inspector panel is an add component button. And this is the way that you can add more components that do different things to your game objects. So for now, let's add a component. And when you click on it, it gives you a search window. You can clear this out. You can look through all the different components that are built into Unity. Or you can start typing. If you start typing rigid body, you'll come up with a couple of options here. The top one is the one that I want. This is just the default. This is for 3D because Unity normally is used for 3D. The 2D one was added on later, and so that's if you're making a 2-dimensional game. That would make sense. So choose rigid body, and then we're good. It comes with some default values that you can just leave as they are. But if you lift this guy in the air, press play, should be able to see him fall down to the ground. Super exciting, right? All right, it is. It is for me. I'm sorry. Okay. So yeah, with that done, we can then start talking a little bit about scripting these things. So for scripting this object, I'm going to first remove the rigid body component. It is fun. It is fun. But if you click on the 3 dots over at the side of that component, you can click on remove component, completely deletes that component. So now this thing is just going to float there in the air. But as you might have seen in games, sometimes you control an object by pushing it around, and sometimes you control an object directly. Your key presses make it move one direction or the other, and it doesn't rely on a physics system or anything to make it move. And really it depends on the needs of your game, which of those you use, whether your keys actually just change the position of your object or whether they apply forces. Okay, so If you continue on down this way, there is a big panel at the bottom, the project panel. Project panel is where you manage all of the assets, all of the stuff that's not necessarily in your scene, but is helpful for your game. Things like music files or images, textures, 3D meshes, and other things like that. This is where we're also going to be storing our scripts. So if you right-click in the project panel, it'll give you an option to create. And you can see there's a lot of things, a lot of different assets that can be created. One of those things up near the top is a C# script. And this is where it gets really exciting. Yes. All right, I'm going to call this C# script player controller. And it's usually a good idea to name it immediately if you have an idea of what it's going to be named, because Unity will give you a default script that's filled out with kind of boilerplate code. You can see that if you have the script selected, it shows you in the inspector what that script looks like. All right, so you should be able to double click on that and open it up. If you made the mistake of like clicking off of it or whatever and you didn't rename it right away, your script will just have a different name for the class that was created for you.
We actually talked about it in naming classes because Visual Studio let you create a class and always have to change the name of the file.
Yep. So if you renamed it right away, it calls it player controller for you. And you'll see that it's already put a bunch of stuff in here for us. System.collections, system.collections.generic. These are things that are very commonly used in games and a lot of software, especially since collections.generic has like our list class. You may be familiar with that one. The Unity Engine API, the application programming interface that's built into Unity, that's provided for you, is accessed with this using directive. And so Unity Engine, that module gives you access to a bunch of the stuff that Unity, the internal parts of Unity are working with. And there are further ones depending on what part of the engine you're working with. So in our class, you can just leave it the way that it's defined. It inherits from monobehavior. So have you guys talked about inheritance at all yet? Okay, familiar with that. All right, so inheriting from monobehavior is important for a component because all components in Unity have to inherit from monobehavior. That's just the rule. It is spelled with a U, which is really unfortunate because they had people working in England when it was when Unity was early in its creation. So anyway, monobehavior provides some way for the Unity engine to recognize this as a component and to be able to access certain parts of it because it knows what to expect. So for example, here is a start function. And this start function isn't just a regular old method. It's a special one that Unity looks for. Whenever there's a component, Unity knows whether or not it has a start function, and it will call that start function when play starts or when this object is created in the scene. So this is where we can do things like initialize our object. Normally, in a normal class, you would initialize the object in a constructor, but in Unity, because Unity is more in charge of creating these components, you would do that work in start or another function that's very similar to start. There's another one called awake. Let me see if it'll fill it in for me. Yeah. So awake is another function that Unity might expect to be there. If it is there, Unity will call this as soon as this object or this script first gets loaded. Start happens a little bit later. So sometimes you get dependencies of objects between each other, and you need one to be sure that it gets set up first, and that's what you use awake for. So use this. All right, there we go. Cool. So most of the time, start is totally fine, and we can do things like choose a new position or whatever. So since every game object has a transform component, we can kind of just assume that, and it's built into the monobehavior class. So if we start typing transform, this is a reference to our transform object. We can do transform dot, and then you can see all the different things that a transform component is capable of. There's quite a bit, especially since the transform component also manages like child and parent relationships between objects. So one of the most important ones is transform.position. And so you can see from the tooltip here that a position is of type, oh, there it goes, vector 3. So that's the three-dimensional math vector data type that's used by Unity and provided by Unity. So if we want to like change this to a different position, we can say new vector 3 and just type in whatever we want. Let's go like let's do 4 units up and 2 units over, right? 2 units forward, I guess, in the Z direction. All right, so yeah, this is how we can set up an initial position if we wanted this object every time that it's created or activated to appear in the same exact position every time. This is usually not what you want. You usually want to be able to choose where its position is going to be in the editor. That way, you know, you have game designers who can move things around and not have to touch the code. So similarly in update, we can mess around with transform.position here. So I'm going to be starting off somewhere up in the air, 4 meters up, and then transform.position, let's do plus equals, let's do new vector 3, and say 1 in the X direction. So update, like it says, is called once per frame. Anybody know how many frames per second is typical in a modern game? 60, right? So 60 frames per second is usually our target because that's the usual monitor refresh rate, 60 hertz, 60 times a second. So to create the illusion of motion, we want to do something every frame, make something move every frame so that your brain thinks that it's actually moving. So that's what we're doing here. I'm going to be moving this thing 1 meter every frame. How does that sound? No objections? Okay, all right. Okay, so let's see. I want to choose my camera, make sure that I can see my object, because I know it's going to start off up in the air a little bit. And then I'll press play and let's see what happens. Nothing.
I don't think you put the script in the GIF of the player.
Yeah, that's exactly it. So I haven't actually attached this script to my game object. And I can attach it to any game object. I could attach it to the plane or whatever, any of these things, and it will behave the way that I had scripted it. So to attach it, the easiest way is just to grab it from your project panel and drop it over here into the inspector. And there it is. All right, so now that our player actually has that script, are we ready? Okay. I missed it. There it goes. It's exactly what we wanted, right? Do you see the position? So this is updating live. What's wrong? What's going on? It's crazy, but I thought I told it to do it like increase by 1 every frame, which is 60 times a second, right? So this is going 60 meters every second. That's pretty fast. What is that? That's like a 130 miles per hour or something. That's crazy. All right, so anyway, what we need to do here is not talk in terms of movement per frame, but rather movement per second, right? That will make much more sense for us. So the way to do that is to take the movement per frame and kind of like chop it into a tiny slice. This is technically integration. It's time integration of your position using a velocity. So that may carry some meaning for you. So we want to take a tiny slice of this velocity every frame based on how long that frame has taken in actual seconds. So the way to do that is to multiply by something that Unity provides, because Unity is keeping track of how time is passing. There is a capital T time dot delta time. All right, there we are. So time.delta time is going to give us that little slice of time. How much time did the last frame take? And we'll multiply by 1 to give us something much more reasonable. Should be now 1 meter every second, right? Much better, much better. So we can work with that. All right, so one of the very common things we're going to do is to control this with some input from the user. That is built in, and there are a couple of ways to do it. I'm going to show you the old way because it's a lot easier and simpler, though less powerful. But there is an object called input. And the input object, you can do input dot, and you can see all of these different things that it can do. Unity is helpful in a way. It gives you sort of 3 versions of each of these input things. So let's look at these ones. There's input.getButton, there's input.getButtonDown, and there's input.getButtonUp. So down is, well, did the button get pressed down? Did the button get released, get button up? And get button is telling you if it's currently being held. So those are 3 important things to differentiate when you're actually deciding how your game's going to be played. Do you want something happen just once when you press the key, or do you want to happen continuously while you're holding the key? I think we want some continuous movement in this game, but you can imagine like a game that's grid-based, where you would want it each time you press the button to make it happen. So let's do get button. With get button, we can call that function with a string that is the button name. So this button name depends on how your project is set up, but there are some defaults. Let's just do, let's see, let's actually do, I think I'm using the wrong one here. Get button, I don't have any specific button that I want to check just yet. So we'll hold on to this thought. What I think I want is get access. Because Unity is typically used for controlling games. Get access is another one that is very similar to get button, but it maps 2 buttons together as one axis. And so I'll use get button later when we're working with like jumping, but get access will be better for movement here. So there are 2 axes that are bound by default to like WASD and your arrow keys. One of them is horizontal. And get access returns a floating point value. This is going to be a number between -1 and +1 that's going to tell you, are you pressing to the left, are you pressing to the right, or are you not pressing at all? It'll give us a 0. All right, so let's make a variable to hold this so we can keep track of that. And let's do this again, but this time with the vertical axis. All right, so once we have those, horizontal and vertical, we can use them and just plug them in to our different axes here. So where do you want to put horizontal, X, Y, or Z? It's up to you, it's your game. X, all right. And where's vert gonna go? Y, all right. Okay, and we'll see how that works out. Let's save that script, head on back to Unity. Okay, so first of all, it's not moving. That's a good thing because we told it to kind of listen to our input. And right now, horizontal and vertical axes should be 0. They're not being pressed at all. If I press WASD or the arrow keys, there we get our motion. Cool. It's a little bit slow. It's also floating up off the ground. That's not usual. All right, but otherwise it's doing what I expect it to do. You'll also notice there's a little bit of smoothing in the inputs. Like keys are digital, they're either on or they're off, but Unity puts in some smoothing so that when you press the button, it doesn't give you exactly 1 right away. And when you release the button, it doesn't give you exactly 0 right away. There's a little bit of a delay there. So it makes it feel smoother off the bat, which is kind of nice. All right, so let's get back into the script. All right, first thing I want to fix is it was floating up and down. I'd kind of like it to move on the plane. What change do I need to make?
Change the start position? Oh, wait, no.
I think that's a good start. We should probably just get rid of this for now. I can comment it out so that that'll still be there for reference. But if we don't change the starting position, it'll be where I placed it in the editor, which is a good thing. So let's stop doing that. How about here? How would I change this so that I'm moving in the along the surface of that plane that I created?
Make it vertical, 0.
Make this,
Or 25.
that's fine. So this will be the y component of my motion. Think of this as your velocity. When I'm pressing a button, I have some horizontal velocity when I'm pressing the button. And if I wanted to move in the XZ plane and not move in the Y direction at all, I can still put vert over here in the Z coordinate. Does that make sense? All right. Cool. So with that, I'm going to test this out. I'm going to move this guy over to the corner just to make sure that our position is preserved. Yep, there he is in the corner. And then when I move, scooting along on the plane. Good. And I can also just jump off. And because I have no rigid body component, I can fly. That's great. Okay, another thing, so the other thing I said that's kind of unsatisfying about this is I'm moving very slowly. I want to move a little faster. So since this is my velocity and it's a vector, I could just do some simple vector math. Do a scalar multiply here. Just multiply this vector by a scalar. Just like I did here. This was making it smaller, but I can choose a controllable constant. So let's say I make a float called speed. Let's do like 10 times faster. And then I can just throw that into this, this expression. All right, that seem good? Okay, so with another variable just multiplying in there, that's a lot better. This is quick, maybe a bit too quick. But sometimes you'll find just programming things, what you're doing is setting up behavior. You're not necessarily responsible for fine-tuning these hard-coded numbers. And so this is a big hint. If the programmer isn't really responsible for this value, who is, and how do you get them to change it? You don't want people digging into your code and having to change this number there. So instead, we're going to expose this publicly so that it can be modified. All right, so let me take it out of here and put it somewhere in the class scope. I'm going to put an access specifier here to be explicit. That is going to be a public variable. And what this does normally, if you're familiar with classes in C#, normally public just makes it so that other scripts, other classes, can access and modify the speed. That might not be exactly what you want, but one of the benefits it has is that also exposing it publicly means that Unity is able to see it. So when I go back into my scene here, you can look over in the inspector and now there's suddenly a speed property showing up in my script component. So this is how you can expose things for like a game designer or a level designer to adjust. Does the speed need to be just a little bit lower? Sure, let's just lower it a little bit. And then when we press play, it should feel a lot better. Nice. All right, there is something else here. I can feel it. So you may come across this in games. When you move left and right, I'm moving at a speed of 7. If I move up and down, I'm moving at a speed of 7. But when I'm moving diagonally, have you seen this before in a game? Moving faster diagonally than just left and right. What I've told it to do is to combine both the horizontal and the vertical together. And their maximum value is going to be 7. But if you use a little Pythagorean theorem there, that's going to be like, I don't know what the value is. What's 7 squared plus 7 squared, all of that square rooted? I don't know. It's going to be close to 10, right? So anyway, we're going to get a speed that's definitely over what we expected, and we don't want the user to like abuse that or for it to feel weird. So instead, what we normally do is we take that into account by normalizing this vector first. So let me grab this vector, and I will make a vector 3. Let's say velocity. Let's just do that for now. Yeah, that seems fine. We'll do velocity here, and then velocity dot normalize. So normalizing a vector is going to make it a length 1 vector. So whatever direction it's pointing is going to become 1, a length of 1. And then when we multiply that by our speed, then we'll get our true velocity, the direction, and the magnitude. All right, cool. So if you haven't taken a physics course yet, too, you'll get a lesson on that as well as we go through. All right, does that all sound pretty reasonable? So this will effectively reduce, if horizontal were 1 and vert were 1, it will reduce them to like 0.707 instead. And then when you multiply by speed, you're going to end up with what you expect, getting a maximum speed of 1, or of 7, sorry. All right, there we go. So now you might be able to tell. I can feel it. This is moving a lot better. If you start trying to move around in circles, you'll notice that it's going a constant speed. right, so let's get back to that, that get button we had in here. This one here. I was thinking I was going to do something constantly with this. We might as well just use get button. So let's do this afterward. Doesn't really matter. But let's say we have a button like a jump button. This is one of the buttons that's already mapped for you. It's by default mapped to the space bar. So I can say, let's see, get button is going to tell us it's a Boolean that is returning. So it's going to tell us true or false whether or not that thing is pressed. So if that thing is pressed, then we can do something like change our position again, plus equals, and we'll try to do a lot of the same stuff we did here. We want to jump roughly. This is going to be more like a rocket boost or something. I want to move this thing upward, so that's going to be in the Y direction, like that. I'm going to need to have some sort of jump speed, I guess, and then multiply that by time.delta time. And this looks like a good candidate for another one of those public parameters that someone could adjust. All right, so jump speed, we'll throw that up here. And it really depends on how gravity is affecting us, but I'll leave it at 10 to see how that does. Let's do 20. So that's just the default, but when we go look at Unity, it will use whatever Unity is telling it to use. All right, so we've got our jump speed. Let's pump it to 20, and then try this thing out. Should be able to move, and then when I hold spacebar, it moves up. All right. So this may not be the best way to move an object because there's no physics going on. So let's go and grab that rigid body component again. If you go to the inspector panel, click on add component, and then choose rigid body. We've got a rigid body component that's going to pull this thing back down against our wishes. All right, so let's move it. And then when I use my space bar, it's going to fall back down. Okay, and flop over. That's fine. All right, so something going on. So I had mentioned it before, but there is a decision you have to make for any given game, whether you're going to be controlling an object directly by modifying its position like I have here, or if you're going to be applying forces. Forces make something behave more physically. It's going to interact better with the physics engine. If it gets bounced around and knocked off of things, you're going to have acceleration involved, which is not the case if we're controlling it directly. And we can, I think we'll move on for now. Just leave it the way it is, but then we'll get back to it and talk about forces, so that we don't get just stuck in this function forever. All right, so let's take a look at another behavior that's pretty useful. Let's see, we do have a rigid body component on here. And so rigid body components allow us to interact with other objects, colliders. So if I create another object, let's make an object. Oh, and I forgot to tell you the other many ways to do this. Let's do a sphere. That'll be fun. All right, that's fine. Let's give this sphere a rigid body component as well. And while we're here, because we're going to be playing around a bunch, if you choose the scale tool. It's also bound to the R key. If you press R, we can make this plane bigger, easier than just typing it in. But give us a lot of room to move around. And then another thing we can do that's going to be is going to change our game completely is we had this main camera just like pointing this way, right? We could make this main camera a child of the player for a really simple rudimentary follow camera. So let me try that out. So now wherever the player moves, the main camera also follows that motion. All right, so my player is off to the side, so this is a little weird, but you could see that the camera is childed to that. All right, we can also see, yeah, that's annoying. When I bump into that ball, the ball is, yeah, I think I'm bumping it around. It's hard to tell on this white surface. But yeah, I bumped into the ball, and it is also making my player rotate, which is making the camera rotate because it's childed to the player. So one thing I can do about that, I can choose the player object, go into its rigid body component, and there's a constraints section where I can say, all right, I don't want you to rotate in all directions. Let's say this is the axis about the, or that the rotation will be about. So the x-axis, I don't really want it to spin that way, so I can freeze rotation on the x-axis. And I don't really want it to rotate around the z-axis either, the blue one, so I'll lock that one. The y-axis I think is fine if we made like an object that faces the direction that you're moving, then I would be rotating around that axis. So we'll leave it like that. And then I shouldn't have that camera getting jostled around. But as you can see, I should probably adjust this a little bit so that the object is in the middle of the view according to the camera. So I can take the camera, switch back to Move tool, or use the W key, and then I can set it up here. Let's get it a little closer. Okay. So there are also some other controls you can do with a camera. If you're attaching a camera like this to an object, maybe not so useful, but if you find a view, like you're in the editor and you're like, this is the perfect spot for the camera to be. So say, let me actually do something like that. I'll be like, okay, I want the camera to be this far away from the player, pointing down at it a little bit, and at this angle, this looks really good. You can select the camera object and then go up to Game Object, and then Align with View. And whatever object it is, it'll move it to where your scene view currently was. So there's where I was when I pressed that. And now my camera, having selected it, you can see in its little mini view over here that it's pointing right at my guy. So this should be a little better. There we go. All right, so yeah, I'm getting bumped around and spun, which is throwing off the controls, that's fun. But we can get back to fixing that later. All right, cool. So let's see. If I have an object like this, I can bump into it, mess around with it. But there are some other things I can do with these rigid body components and with these colliders. Sometimes you might run into something and you want to know in your script what happened. Maybe you want to give points for running into something, or maybe you want to hurt the player or do whatever. make them bounce away from it, anything like that, any kind of behavior. Let's create another cube. I'll make this one a bit bigger. Oops. Let's call this like goal zone. Scale it up a bit. Maybe even flatten it. And then I'll move it to one side. All right, so there's a goal zone object, and what I might want from this goal zone is for it to detect when the ball goes into it, right? That might be a kind of game that we're creating. So for that to happen, I should add a component. I should add a rigid body component to make sure that it can detect rigid bodies or other colliders touching it. And then when I look at this component, there are things about it that I don't want. I don't want my goals affected by gravity, so I'm going to turn off use gravity. Maybe I don't want them to get knocked around either if they get collided with. But if this is a goal zone, it's more abstract. It's like the empty space inside a goal. So maybe I don't want it to be treated as a physical object at all. So one of the things I can do is on my collider component, I can check this box, is trigger. So is trigger immediately disables all collisions for an object, and instead just gives you a way of detecting that a collision has happened or a trigger event has happened. So with that, I'm going to create a script that I can attach to the goal zone that will do something whenever the ball gets into the zone. So right-click in my project panel, create a script, and let's call this goal controller. All right, and so I don't forget this time, I'll just drag it right onto the goal zone. You can do that into the hierarchy panel, or you can select it and drag it into the inspector. So we have our goal controller script right there. And when I open that up, I don't really need the goal to do stuff. So I can just get rid of these. Not that kind of stuff. Instead, there are other special functions that Unity will call when a certain event happens. So you can find a pretty decent listing of them if you just start typing on, because a lot of them are prefixed that way. And the one that I want is on trigger enter. You can see that there's on trigger enter, on trigger exit, on trigger stay. And these are similar to when we were pressing buttons. Enter is when some object first enters the trigger area, the trigger volume. When an object leaves the trigger volume, or on trigger stay is every frame while an object is inside the trigger or colliding with it. So let's do on trigger enter, and we can say, all right, there's another object. And I'll just do, when this happens, I will just print out a message to our, effectively to the console. We can do that with debug.log. This is a general purpose logging tool. You can use it anywhere in your code. And it will just tell Unity, print this message to the internal console. So I'll say, goal. Okay, so this is just a debugging tool. It doesn't happen in the game in any way that's going to be displayed to the user. So I'll leave a note. This is something we got to do later. All right, so when that is triggered, we'll get that goal thing. Let me just lift this up, make sure it's not overlapping with the ground. That's fine. Let me see if I can go score a goal. Okay, I think I just have to bump it to the side, not get in the way. Okay, it's going. This is pro level soccer. Okay. So there is another panel down here, the console panel, and you'll see our little message pop up right there. You'll also see the latest message down at the very bottom. There's this gray bar at the bottom that just tells you what the last thing printed was. You can click on that to hop over to the console panel as well. So it looks like it worked. We got a goal. So let me go celebrate by running into the goal multiple times. Right? So maybe not exactly what we wanted, but it's doing exactly what we told it to do. When it detects something, a collider going into it, it's going to print out goal. So we need to be a little smarter. We need to say, all right, there is a special kind of object that should be able to produce that message. And it should only be this ball, right? So if we select on that ball, up at the top of the inspector, there is a tag field. And this is a way that we can just apply an identifier to this object. And we can apply this identifier to any object in the scene if we want to. We could have multiple balls in the scene where we tag them all. And you can see that there are some built-in tags that might be useful to us, but ball is not one of them. So I'm going to go down to add tag. When you go to add tag, there's a tags and layers view that comes up in the inspector. And the list of tags is currently empty. So I'm going to add a new tag here. And let's call this ball. You have to remember the capitalization and the spelling that you use. Be careful of spaces because that can throw you off if there's a space at the end. We're going to be using this as a string in our code and comparing against that tag to see if we have actually had the ball cause that trigger. So once you create the tag, this panel doesn't automatically apply it to the object that you added it from. You have to select the object and choose that it's going to be tagged that way. So it now has the ball tag. And then in our script, this should be conditional. This should be conditional based upon whether or not we've actually detected the ball. So this other object is coming into this function. This is the collider component of the other object. So I want it so that if other dot, and there's a function compare tag that I can say, all right, compare with the string ball. And so if that tag for that other object happens to be ball, then we're good. Then we can celebrate. Okay. So I'm going to do something similar to this just to show you a very similar API for an event for collisions. We do have a trigger object. We also have two objects that actually do collide with each other, the player and the ball. So just to kind of expose this to you, let's do on collision enter in the player controller. So I'm going to make it so that when the player touches the ball, it says something, just so that we know that there has been a collision. So when we have a collision, you could do all sorts of things. Like if we had a game where there was some like the player somehow captures the ball so that it's dribbling and not just knocking the ball around. That could be a thing, or if it's like the goalie character and it actually catches the ball. You can do all sorts of things, or we can apply extra powerful kicks or something. Here we can do the same thing, except that instead of being given the collider component, we're being given a collision object, which is just one step more information about what's happening. So I can say if collision dot, and then you'll see there's a collider property in the collision. I can do the same thing I did in the other function. Collision.collider.compare tag. Check to see if what was involved in this collision, the other object's collider, had the ball tag. And then we can say, just temporarily, kick the ball. All right, seems pretty good. I'm not going to test this out, but we'll just pretend that it works. There's one more thing I want to do before we take a little break. This thing looks like garbage. Would you agree? Okay, it's not that much garbage. I've seen worse, honestly. But it's missing a lot of stuff. If I look in my project panel, there's really nothing to go on here. Like, here's the scene I'm working in. Here are my scripts, but there's nothing useful here. Unity provides an asset store. If you go to assets, does it have it here anymore? They changed where the asset store is. They made it so that it's not built into the editor anymore, but that it is just their website. So it may not be where I expect it to be. Is there a, yeah, it's still around, except it says it's not. Okay, so anyway, let's search online. That's fine. All right, so one that's really, really good to use for prototyping are the standard assets. And you can search for that. It should come up with this one, standard assets for Unity. So in the asset store, it provides just an easy way to download and keep track of the assets that you have purchased, or you can get free ones here as well. I'm just going to grab these standard assets because I know what to expect from them, but you can explore this and try out other ones. So I'll click on to that one, add to my assets. I think I'm not logged in. There we go. All right, need to update passwords. All right, so we got this. When I open it in Unity, it should give me the option. Oh my goodness. I don't want to sign in here. Okay, let's skip it. No, it won't let me. Oh my goodness. All right, unforeseen. Let's hope I remember my password. Oh, that was almost a disaster. Okay, so anyway, you can see. I guess I own some assets or something. But you can also let's see. If I click on Open in Unity, it should bring me right to that particular asset. It'll give me information about it. Let me look at it or read more about it. But what I want here is the import button. If you haven't downloaded it yet, it should also give you that option. And then you can import. And importing an asset package will add it to your list of assets in your project folder. Okay, so it should pop up with this importer dialog. And you can use this to make sure that you are importing the files that you expect to. This is a whole lot of files. So there's a lot of cases where you don't want to import all of these things. Let me see, is there anything I really definitely don't want? I don't know, maybe I don't want this aircraft jet in my thing. I could take that off. But yeah, you can see like, I could spend more time going through these and saying, no, definitely don't want that. But I'll import it anyway. Let's just do all of it. The downside of importing all of it is, of course, it's going to be a lot of files. It's going to be a bigger file size, and that's going to affect when I'm using my version control. All right, so that should take a minute. How's it going so far? Any questions about anything? Does it seem useful? Seeing some good stuff? All right. So once this is done, I'm just going to slap a texture on the ground, maybe something dumb on the characters, and then we'll take a little break. And after the break, we can talk more about certain behaviors that are very common in games, aiming and shooting. Those are pretty common. And we can talk about some of the very rudimentary AI stuff that's in Unity. Not like anything like neural networks, but like pathfinding. There's a built-in solution for that we can use. All right, so it looks like it imported. Let's go back to our scene. In our project panel, you can see now we have, we had the scenes already, we had our scripts, but we now have standard assets and sample scenes. Cool. I'll go explore those. But first I want to make sure that my stuff doesn't get lost in all of these other things, so I'll do a little organization here. Let's create a folder. So if you right-click in there, go to the Create option, choose Folder, and we'll just call this Scripts. Then I can grab my scripts I've made so far and drag them in there. So Unity does keep track of the references between objects in your game. So if you have to reorganize, move objects to different folders and stuff, it understands that and it knows. So it won't lose track of them, which is very nice. I do have an error here, I think because that package needs to be updated. Yeah. So it won't let me play as long as that error is there. This will give you a chance to see something that Unity has provided that is not perfect yet. So let's see, it says error. GUI text is obsolete. GUI text has been removed. Used UI.text instead. So when you are trying to compile or run your game, it'll compile your scripts, and sometimes there are going to be errors. So you can double click on that error, and it should bring you to the to that spot in code where that error happened. So here it's complaining about something that was provided for us. This is really not our fault. But it says that this type doesn't exist in this version of Unity. Things have changed, so don't use this anymore. So I'll just follow its, oops, that's not it. I'll follow its instructions. It is said to use UI.text, but I believe this is in the Unity Engine module. So I can make this just a little cleaner. Do Unity Engine.ui, and then text. Okay, and it looks like as far as IntelliSense cares, that looks like it fixed it. Let's see if that actually fixes it. Okay, so it looks like no more errors. A bunch of warnings about some of the stuff we imported, but we'll just ignore those for now. You can click clear, and it'll also clear that up, and it'll probably remind us later about those warnings. All right, so in our standard assets folder, we can go look at, where is it? Let's try environment, terrain assets, surface textures. So there are some things here. You can just grab one of these textures and drop them in there. What that did was automatically create a material for it. And we'll talk about materials more after the break, but let me just get these going. Let me make the goal zone look really stupid. You should never put a normal map as a diffuse texture on things, but I just did. So there we go. All right, and that looks much better. Cool. So let's take let's say a 10-minute break. Just cool down, hang out a bit, let that absorb a bit. And if you have any questions during that time, you can ask me. Sound good? All right, so at 12:30, let's get rolling again.
Yeah, well, you pick one, it's not bad.
Okay, are you guys all set? Are we ready to pick up again? All right, so in our first half, we had gone through introducing Unity and setting up some of our basics. We've got objects that can move around, we can control them. They can interact with each other now, which is kind of neat. They have like collisions at least. So I guess we were kind of moving somehow toward a soccer game, but that's definitely not going to happen. So in this second part, things are going to break. We're going to make this definitely not a soccer game because there are common behaviors I want to show you that have nothing to do with soccer. Yeah, we'll see those. And my demo is going to become much less of a game and much more of a tech demo. If you're looking for a complete thing, it's not going to happen. But we'll see some pieces of things, and as you're building your own projects, you can pick and choose what kind of pieces of behavior make sense for you. All right? Okay, so the first thing I'm going to do is kind of to detach us from this whole soccer thing we were going for. I'm going to take the camera off of the player at this point. It's going to cause more issues when I'm trying to pin down the control of my player and what kind of things the player can do. So I'm going to grab the main camera and just drop it off in an empty spot in the hierarchy view. So that's back out there. And when I press play, I should be able to just freely run around now. And the camera will stay put. Okay, good. We're back to this. So the reason I'm doing this is because I want to be able to tell what my player is doing for this next behavior. So I said before that we might want to make something that like aims and shoots and stuff. So let's make that happen. I want to have my player object maybe always facing some other object. We'll think about that. Let's think about if that's going to work for us design-wise. But let's create an object. I'll create a 3D object that's just a sphere. And I think I already glossed over it a couple of times now, but the other ways to create these things, let's do that. There is a plus drop-down menu here that should look really familiar. This is that bottom part of the right-click context menu. There's also, if you go to the game object menu, that same thing is right up here. So there are several ways to access this same menu. All right, so let's make that sphere. We'll call this like our target, right? And I'll take my target, drag it somewhere. I want to put it into view at least, maybe up here. That looks pretty good. So I can double check. It looks like it's a little too high for that camera. All right, I could also rotate the camera. Okay, That looks fine. Okay, so I want to have some sort of relational connection between these two objects. For that to happen, they need to be able to refer to one another in some way. So let's start with the player object. This guy's going to be doing most of the work. If I wanted to go open up my script, I could go through Visual Studio. I can also look on the component in the inspector, double click on that script, the player controller script. It should pop right back open. All right, so if I wanted to always like be looking at a certain object, I can make a public variable. Let's make it a of type game object, and I'll call this target. So if you remember, public here is going to make it available to other scripts, but it's also going to make it available to Unity, the editor. The editor is going to be able to fill in this, this variable. That works for most variable types. So this happens to be a game object, and you should know that like floats are value types, so they're just numbers, raw data. Classes are reference types, so this is going to be a reference to some other object that exists in the game. So we'll leave it like that for now. And assuming we had a target game object that we can look at, we might want to look at it every frame. So here in update is where we're doing all the stuff that happens every single frame. And we'll want to mess around with the transform component again. Transform.rotation this time. So has anybody done rotation in 3 dimensions in like a math class before? Have you ever had to deal with that? It's horrendous. It's a mess. Mathematically. There are several ways to do it. One very common system of doing rotations is using what's called Euler angles. Has anybody heard of Leonard Euler or anybody like that? So with Euler angles, you give it effectively a rotation around each of the different axes. But there are limitations to that model. Let me jump back to the editor for just a second. I'm going to comment this out so that I don't get a compile error while I look at the editor. Okay, so up at the top with the player object, you can see a rotation, this rotation field, I guess, this property. And if you mess around with one of these, you can click and change these. These are measured in degrees, X, Y, and Z. You can also click on the actual label, X, Y, or Z, and drag it, which gives you a way to just watch what's happening there, right? So we can see our guy rotating. And this acts very much like those Euler angles. They give us a way to say, all right, rotate this much about the x-axis, this much about the y-axis, and this much about the z-axis. But one of the issues, if you especially need to know if you go into aviation, a problem with Euler angles is an issue called gimbal lock. If you're free to rotate about each of these axes, and then you rotate it in such a way that you can rotate it in such a way that 2 of the axes end up collinear, and you're rotating about the same axis, whichever parameter you're changing, you lose information. That's the state of gimbal lock, where you're not able to rotate about 3 independent axes because 2 of them have aligned. So really dangerous if you're in an aircraft that can't, where the steering system can't deal with that. But for us, we just have to understand that Euler angles, they have their limitations, and they're not like the always the best tool, even though they kind of make good sense here if we want to rotate about a specific angle. But sometimes they just end up acting a little bit weird. What we can do, though, let's change this back to zeros. Under the hood, Unity is not actually using Euler angles. We can type in Euler angles, but what it's actually using is not that. Instead, back in our script here, transform.rotation was called a quaternion. And as a crazy word, who was it? The mathematician Hamilton who came up with these. It's a way of expressing rotations as a separate kind of object. The best way to think of it is that you can express rotations as a matrix. You can do 3D rotations using matrix math. And you can convert a quaternion to a matrix and a matrix to a quaternion, usually pretty easily back and forth. But one of the advantages that quaternions have is that it's really just 4 variables, 4 numbers to express a complete quaternion, which is really, really cool. I won't get into like the details of the math, but there are some really popular YouTube channels that go into it. What's that one? 3 brown, 1 blue. Is that the one? Anybody familiar with that YouTube channel? It's amazing, an amazing math YouTube channel, and they have great stuff on quaternions if you want to learn more about it. But we're going to treat them as essentially black boxes for rotation, and just know that we have to create quaternions, and Unity gives us the tools to do that. So if we do transform.rotation and set it equal to something, we have to create a quaternion. And most of the interface there is through the quaternion class, quaternion dot. And so they give you the most used ones up here. But you can see some of these other things that quaternions are capable of. So quaternion dot, and we can say, here it is. This one looks pretty useful. Look rotation. This is like cheating. It's going to do the math for us. So look rotation, we just have to provide it with a forward vector. A forward vector is usually enough here, where we're just saying what direction do you want to point at. However, it would be perfectly valid for my object to be facing a direction with its head pointing up, or its head facing to the side. Those would still technically be facing that direction. So look rotation also takes an optional parameter for the up direction. So we can make sure that that stays up. And I think that defaults to Y being up. So I don't think we have to specify it, but we could. For now, though, what we want is a vector that points us in the direction of that target object that we're trying to look at. So this target object. So to do that, I'm going to do a little bit of vector math. Let's see, vector 3. I'm going to get a separation vector. And if you're unfamiliar with how vectors work on an intuitive level, a good way to think of it is if you're trying to get from somewhere and to somewhere else, you're going to need some sort of separation vector or difference vector. Always take your destination minus where you're coming from, your source. Destination minus source. It feels a little bit backwards because as we write it out, you'd rather say I'm coming from here, going to there. But mathematically, you want to go to minus from. So we're going to take our target dot, and our target is another game object. It has a transform component. So I'm going to get the target's position and subtract our own position, transform.position. All right, and that gives us a separation vector. Just the difference between these two vectors gives us a vector that points from where we are to where we want to go. Does that sound good? Pretty straightforward. Now this separation vector starts where I am and ends on the target, but I want to treat it more as just a direction. So I don't care about the length of the vector. So this is a good place to normalize that vector. Separation dot normalize. And then I've got something that's a direction vector telling me where to go, what direction I need to go. So I can put it right in here. And just for completeness, since we said we want upwards to be the y dimension or the y-axis, positive y-axis, we can put that in explicitly. I'm pretty sure if we leave it, it uses that anyway. But I also want to show you there's a static property of vector 3. Vector 3 dot up is the same exact thing as writing new vector 3 0 1 0. So with 1 in the y-axis. So it has these built-in ones, vector 3.0 if you just want all zeros, and so on. They're easier to read in some contexts. And without using new, it may also avoid some garbage generation. Depends. Have you talked any bit about how C# does memory management?
These are freshmen, and
Yeah.
we don't even really do C#. We do 2 weeks just to give them a hook to some graphics.
Cool. All right. Well, in games, sometimes we care about when memory is being allocated and when memory is being deallocated and released. And so C# is really nice in that it does it for you. It takes care of it, and you usually don't have to think about it at all. So usually it ends up being an optimization issue. All right, so transform.rotation, we're setting it to a new quaternion that is from this quaternion.lookRotation function, pointing in that direction, which is from where we are to our target, and keeping our head facing up. All right, that should probably work. So let's check it out. All right, so nothing, but if you look down at the bottom, this. Oh no. Oh no. Thousands of errors. I must have done something really serious wrong. Okay, but if we just read the error message, unassigned reference exception. Okay, that's a really good hint about what is going wrong. The variable target of player controller has not been assigned. You probably need to assign the target variable. Okay, yeah, all right, thanks. So it's telling us that we haven't actually told it what the target is. If you click on the player object and you go look in the inspector for the player controller script, target is set to none. This is equivalent to null if you are testing it. So I can, there is this little circle selector on the side. If you click on that, it opens up another panel that lets you choose objects. So I can choose from my assets, I can choose from what's in my scene. There's the object that I want, but I'm not going to select it yet. Because what I usually do, I usually grab it from the hierarchy panel instead. This is the object, and I'll drop it right into that slot there. So now the player controller starts off referencing the target object, like I had intended. Okay, we should see error messages disappear. Cool. All right, much better. Yeah, this is cool. We are pointing straight at that thing, which is a little bit weird. Maybe we'll live with it. We'll see. See how I feel about it. But this is looking straight at the thing on all axes, no matter where I go. If I went above it or below it, it would still work perfectly fine. You can watch my rotation change over here. And sometimes these changes will make sense, but sometimes they will not make perfect sense because, again, under the hood, Unity is using a quaternion and not, it doesn't actually care about these values as much as we expect it to. All right, so now with that separation vector, with that direction vector of where I'm pointing, I could use this to be like, oh, well, maybe I'm pointing at that target and now I want to shoot a projectile, fire something off. So hopefully we'll run into a whole bunch of issues here that we'll have to fix. So the first thing we have to do is say, all right, well, what object are we going to be shooting? What is the projectile itself? In Unity, I'm going to create a projectile object in my scene. I'll right click in here, create, let's do like a sphere that's little. I'll call this bullet. And I'm gonna scale it down so that it looks more like a bullet. All right. And I don't really care where it's positioned right now because I'm not going to be using it in the scene as a normal object. I'm going to finish setting up some of these things though. I know that I want it to be able to move on its own accord. I could do that with physics, the physics engine, which would be fine. So I'm going to add a component, a rigid body component to this object. Save that. And all of this is probably fine for now. Okay, so we have one bullet, but what we really want is the ability to create lots of them whenever we choose. So go over to our project panel. Let me go back up to my base assets folder. And I'm going to take this object and drag it into my project panel. What this has done is created an asset. Just like we manage all of our assets in the project panel, it has created an asset called a prefab. And the prefab is a prefabricated object. It's one that we've already set up to have all of the properties and behaviors that it should have. And it is now tied to this one in the scene. You can see the one in the scene, the name of it turned blue. It is connected to a prefab. And so whenever I change this prefab, let me change the scale to like 0.2 on each of these axes and go back to my bullet in the scene, that bullet has been updated. So if I had a whole bunch of these, like if I drag this prefab out into my scene, all the changes that I make to the prefab are going to affect all of the instances that are connected to it. Now I don't really want 3 bullets in my scene. So I'm going to select them all and delete them now, which is safe to do because I have that bullet prefab. I can always create more if I want to. And I didn't really have the intention of having one bullet just sitting there hanging in the air when you start the game. So this is good. All right, so if the player is now going to be able to fire bullets, it needs a reference to this prefab. So I can do that in my script. Let me go back to the player controller. Game object, let's call this, I'll just call it bullet. It'll be easier to type. Okay, and I'll show you another thing here. I've been doing this all along where I've just been making them public. Which I said before is sometimes not exactly what you want. Sometimes you want maybe this reference to the bullet game object should be exposed to the editor so that we can make changes to it in the editor. But you don't actually want other scripts to be able to reach into the player object and change its bullet. I don't know. It's up to you how your game works. But normally you would make these private so that they cannot be accessed by other scripts. But then that makes it so that the Unity editor can't see it. There is a special annotation you can use called serialize field. So if you put serialize field in square brackets in front of this, this member here, it's going to do what we wanted it to do. It's going to expose it to the editor. but it's also going to keep this bullet private so that only the player controller is allowed to mess with it. All right. So let me just double check. We'll go into the editor, and if you scroll down to the player controller script, we should see the bullet still. It's not, hasn't been initialized to anything yet, so it's still none. We can grab this bullet, drop it right into that reference field, and we should be good. All right, so we have to remember this bullet is a prefab. It's an example of a bullet that could be created. So we're going to have to choose when we create it and say this is what we're creating it from. So down in our update function, where we've been doing all of our input work, I'm going to do another one. Let's do it near our jumping. If input.get button down. So let's say we only want to do this once every time you press the button down. Another mapping that is available by default is Fire1. So in here is where we're going to make this happen. So we'll throw this down, talk about it, and then I want to just explore where these names come from to show you where the linkage is for that. All right, so we want to create an object. The MonoBehavior class has a function called instantiate. And so instantiate allows us to effectively clone an object, make a complete copy of it. And it's going to appear in the scene. So we want to make a copy of the bullet object. And you can see that there are lots of different overloads, different versions of this instantiate function. And we're going to have to carefully choose which one makes the most sense for us. So the first one lets us just clone an object. All right, that sounds fine. This next one lets us specify that it should have a parent object to start with. Maybe we don't care about parenting bullets to anything. We have some other ones. This one lets us specify a position and a rotation. That sounds useful. So if we created an object, I think it would be good for us to say where the object should be created and where it's going to be pointing. That would be nice. Another one that adds on a parent, and then we can browse through some of the other ones that are sort of redundant. Okay, so great. I think then what we want is this version, the object we're creating, the position, and then the rotation. So position. Let's just create it at the position of the player. That's where it's going to be coming from. And then the rotation, we could use just a default rotation, like no rotation. We would do that with quaternion.identity. So the identity rotation is going to be no rotation at all. That's useful for a lot of cases. In this case, though, if our bullet were shaped like a bullet, we kind of want it to rotate the way that we're facing. So we can use the same rotation that the player has, transform.rotation. And that should work fine. So that bullet is going to be created at our position with our rotation. Instantiate also has a return value. It returns the game object so that we can do other stuff with it. I'll leave that off for now, but we will need to do something with it soon. All right, so yeah, let's get in here and see what we've got. Okay, so the default mapping for Fire1, I believe, is the left mouse click. Wow, it's working. Ship it. All right. Okay, what are some problems with this? Where do you start? All right, help me out though. I don't understand anything. What's going on with this and what's wrong? What needs to be done better or change?
These bullets.
Yeah, these are supposed to be bullets. They need some velocity, right? Okay, so right now they're just kind of like pouring out. All right, so let's give them a velocity. We know that this bullet object has a rigid body component, and the rigid body component is responsible for interacting with the physics engine. So this is the one we're going to be using. I'm going to say game object. Let's just call it, I don't want to call it bullet. I'll just abbreviate it GO for game object. All right, so we get a reference to the game object that has just been created. We can go into this and say, all right, well, hey, game object, give me a component. So the game object, again, is just a container for components, and we want to access the rigid body component. So getComponent is a templated function. It's a generic function where we can specify which type of component we're going to get. And so this will go through and give us the first component that is a rigid body component. And I need to catch that in a variable. All right, there we go. So we know that our bullet has a rigid body component. It's possible that an object might not have one. So you can check just to be safe and careful. You can say if RB is not null, then we can do stuff with it. If it is null, that means it didn't have a rigid body component at all. All right, so we're good, and we can do RB dot, and we can see what a rigid body is capable of. You'll see a lot of the things that you saw in the inspector. There are some properties that we can mess around with. There are also some functions that are really useful, like add force, add torque, or things like that. We can mess around with the amount of drag or all these crazy things. Let's go down to velocity. So this is probably a good one to set. RB.velocity is a vector 3. Okay, all right, we know how to work with those. So we can make this a new vector 3. But then we have to figure out, well, what makes sense? Like, which direction is this going in? And that's not necessarily the easiest thing to just throw out here. If I put like 200 in the x direction, then it's always going to be going in the x direction. I want this to be a little better than that. So one thing that I can do, I can say, all right, well, it has a rotation. This rotation is the rotation for the player. That's also the rotation that the game object should be getting. So I can go ahead and use this rotation here in some way. And what you can do with quaternions is multiply them by a vector to rotate the vector. So I can take my quaternion transform.rotation and multiply it by some vector to get it to rotate. Now this is going to assume, let me see, I'm trying to think of how this works. I think it'll assume that you're kind of facing forward, and then it'll rotate from that position. So this should be more like, usually the positive z-axis in Unity here is considered forward. So let's do like, if I give it a velocity, I want to give it a decently high velocity. 100 meters per second seems okay. We'll see if that's too fast. But yeah, we take our rotation, multiply it by the vector we're going to rotate. so that we get a rotated version of this vector pointing in whatever direction we were rotated. All right. Okay. It's doing a thing. Oh. All right, that's not what I wanted to do. All right, it is doing better, right? There is still an issue. Did anybody notice what the well, one of the big issues going on right now is with this guy? Yeah, it was like hitting himself with the bullet, right? And the bullet was just blasting him forward. So I didn't say anything about bullets shouldn't collide with the player. Why shouldn't they? But I've decided now that they should not. I think that's pretty safe. So a way we can go about disabling collisions between these objects, if you go into the editor, go up to Edit, and then Project Settings. This is a very important menu. This menu has a ton of stuff in it, but the one that I'm looking for is Physics. And this one can be a little bit misleading because what we really want is not all of these parameters for the physics engine. What we want is down at the bottom. So you can see a collision matrix. These are enabled collisions between different types of objects. Default is what most of these objects are already. So I could disable collisions between default objects and other types of objects. But it looks like I don't have all of the different types of objects that I'd like to have in here. I want to make one that's kind of like specifically for bullets so that they'll pass through the player. And so if I go to tags and layers down here, we'll see something familiar. There's a ball tag already up here because we've been here before. And I'm going to expand the layers option here. So these are those layers that show up in the collision matrix. And I'm going to add one of my own. This is going to be player projectile. Since I'm going to want to disable collisions between specific things, not just player projectiles with everything, I'm also going to throw down another one called player. So these are called layers, and they're really just categorizations. They're similar to tags. That's why they are in the same menu here. But where a tag can kind of give a unique identity to an object, a layer is used by other systems, most significantly the physics engine, to kind of determine if it's in this category or that category and how they should interact. So I'm adding a couple of layers here, and then in the physics menu, it should be there now. I can see in this matrix that player projectile and player have a checkbox where they meet up. I want to uncheck that, so now player and player projectile will not collide. I could also disable players and players from colliding with each other. And I could also disable player projectiles from hitting other player projectiles. And this really depends if you want your own projectiles to be able to knock into other projectiles. But I'm going to turn it off for now to make this a little easier for us. Okay, so that looks good. With that, we will now have to assign the layers to these different objects. Our player object, I'm going to select that, and up here where there was a tag, actually I'm going to tag it as the player, why not? And then layer, I'm going to also put that on the player layer. Then our bullet object needs to be assigned to the player projectile layer. So I'll select our bullet prefab, and give it that layer. There we go. So that's all the information that Unity needs to know to disable collisions between these things. This should work a lot better now. Cool. All right. Probably one more issue going on here. Has anybody ever seen this happen in a game before? You're going so fast that you just clip through a wall. That's what's happening here. Our bullets are going too fast, so you can actually see their positions from one frame to another, and they are going completely to the other side without intersecting with the collider. So there's no collision. This has to be handled pretty carefully, but thankfully the physics engine does have support for it. If you select the bullet object, go down to its rigid body component, there's a collision detection option, and we can change this to continuous. So continuous collision detection is essentially going to sweep the path of the object from where it was last frame to where it's moving in the next frame, and treat that as its collision box, so that it actually hits things if it's moving super fast. This is computationally expensive, so you don't want to enable it on every object, just the objects that you know that are going to move very fast. Cool. Looks like it's kind of working. Okay. I think we're doing all right. Okay, so this, let's see, we want to talk about this a little bit. Let's go find where this is. So let's go into Unity, Edit, and Project Settings. In here you'll find, where is it? Yes, this is the one. So in here you'll find Input Manager, and in Input Manager you can expand the axes, and it shows us a bunch of these names, and some of these are familiar now. Horizontal, vertical, Fire 1, Fire 2, oh, those exist, Jump, and others. So we can expand these and check out how they are mapped. It looks like Fire 1, we could be using left control this whole time, that's great. Or mouse 0, I guess that means the left mouse button. Fire 2 happens to be mouse 1, which is probably right click. So if we wanted an action on right click, we could do that, and we have Fire 3 as well. Let's take a look at horizontal. Here we have left mapped as the negative part of this axis, right as the positive. We have alternate A and D. But there's a cool thing down here. This is an additional mapping. You can have multiple named the same thing, and it kind of combines these mappings. So down here on this other horizontal mapping, it doesn't say any buttons, but instead it is a joystick axis using the x-axis of your joystick. And so this is how you can set up like using a gamepad, using an Xbox controller or whatever. So a bunch of these are already set up for you, which is kind of nice, and you can use them as an example. And while we are treating Fire 1 as a button, it is like listed here as an axis. You could set it up in a weirder way than this, but it works. This is also a pretty strange system, kind of like a little weird to work with. If you wanted to add a mapping, you have to change this size of the number of mappings first, and then it'll add extra ones that they can mess around with. But we're going to just leave the default ones. It's just good to know where they come from and how we can check on them. All right, so we got that done. So let's see, what do we want to do next? Let's say let's say that our target we might want to change it. It might not always be that one ball that's sitting there that we want to shoot at. One thing that we can do that's kind of interesting and flexible. Where's our target? Yeah, there's our target. So our target is just this other object. But there was this option in our menu to create an empty game object. And you can see with an empty game object, it's just a transform component. It's like, how useful is that? But really, that's all we've been using about the target. We've only been using its transform component to say, here's a position I'm shooting at. So our target object didn't need to be a sphere. It doesn't need a mesh renderer or anything like that. It doesn't need a collider. And we can still treat it as like a target, but it'll be invisible once we do that. So this is one way that we could implement a sort of targeting system. We just take this invisible target and move it to wherever we want to be shooting. Does that make sense? So I'll at least get us started in that direction, selecting this target, and I can get rid of these rendering components, get rid of the collider. Yeah, so it's just an empty object. And when I play it, everything will work just the same, except there's nothing there that I'm shooting at, right? So this can be a way to try to work with targeting and move the target itself. Another way we could do it is say like, all right, let's look around us and find like what's the nearest enemy, or maybe I even put some controls, like a script on this target object, and I give it some controls so that I can move my target around, like using the mouse or something. I'll leave that for now, but there are a lot of options that we can do with it. One thing that does happen, though, is that if we're just shooting off a bunch of projectiles, they fly off forever. There was nothing telling these bullets to ever eventually get destroyed. And if they're moving really fast, but I can almost watch them. Some of these bullets. Oh, there's one. These bullets are flying out there, and they're never coming back. They're never getting destroyed. So we should do something about that. At least free up some resources. We don't need to clutter the world or bog down the physics engine with a bunch of bullets that are flying off forever. So I'm going to make a script for the bullet that's going to be in charge of destroying this bullet. We could do a whole lot of other interesting things with bullets, but this will be good enough. So I'm going to add a component. I'm going to add a new script component. I guess I'll create it the way we have been. Right-click where I want to create a script, make the script, and just call it bullet. All right. And then I can add a component. When I add component, bullet will come up in my list of components that I can add. And there we go. It is attached. So another way for us to attach a script component. I can open that up. What I want to do is tell this bullet that it should destroy itself after a certain amount of time. And I can do that in its start function. As soon as this thing's created, we can say destroy. Now, Unity is kind of nice to us. We can say destroy game object. So that's talking about this game object. And it gives us an optional parameter here for how long we should wait until it is destroyed. That's so handy. You can just destroy, and that will destroy the object right away. Be kind of pointless for a bullet. Or we can say after a certain amount of time. So let's say like 10 seconds. It'll get destroyed. But we also might want to put some behavior in here for when it hits something. Let's say on collision enter, we can start off by saying, all right, let's destroy our game object if you hit anything. So that seems pretty good for our bullet. This is another place where we could like change a score or whatever. All right, does that make sense? Okay. So I want to set up something to be able to test that. Let's make like a wall. So I'll make a cube, call it a wall, and I will just use scaling to try to stretch it out. There we go. So it comes with a collider already, and that's all we need for the ball to hit it because the ball has a rigid body component. All right. So now we should be able to see if I miss the wall, bullets fly off for 10 seconds, and then they should start destroying themselves. Oh, I didn't. Did I put that? I did put the script on there. Okay. So the bullets all destroyed themselves, or if they hit the wall, then they destroy themselves immediately, right away. Cool, that looks pretty good. All right. And so, of course, as I said at the beginning, I'm not going to be able to cover everything. There are tons of other things we'll still be able to do. I'm trying to think what's the most impactful for you now. Probably two things. We can talk about navigation meshes so that objects can find their way around the world. And we can talk about UI. And I think those two things will finish us off for the day. Does that sound all right? Okay. So this is becoming definitely not soccer. But it would be cool if there were people trying to play soccer while we shoot at the, I don't know what's going on here. But there will be people trying to play soccer. Let's create, let's move this camera out a little bit. This is going to be the weirdest sport. Okay, that seems fine. So now I can see most of the playing field here. I'm going to create an object. I'll make it a capsule this time, because that looks like a person. And this will be a soccer player, I guess. All right, this thing needs to go up. Okay, so the capsule by default is 2 meters high, which is like a human. We'll just say that. And so what the soccer player should be doing is trying to go after the ball. That's all I'm going to do. It's just going to chase the ball. Let me put him in a place where if he goes for the ball, it will push it into the goal. That would be cool. All right, so soccer player, go to the ball. To do this, I'm going to have to add a script to the soccer player. So let's create a new script, soccer player, no spaces. Okay, drop that on the soccer player. And I'm going to go into that script and add a reference. Let's do our serialized field thing. All right, here's the ball. So that's where we're going to be aiming for. But I'm going to try to take advantage of Unity's AI system. I don't want to have to figure out, like, I don't want to have to point them toward the ball or figure out obstacles and stuff like that. Unity can do that for me. So putting in that ball reference is going to give us a destination, kind of a target for our AI. To set up the AI, I'm going to do two things. One of them, on this soccer player object, I'm going to add a component. There's a NavMesh agent, and that is what we're looking for here. NavMesh agents are one form of AI, and most of this stuff is probably fine just to leave the way it is. These are mostly parameters for how close it gets to stuff and how fast it moves, so you can change some of that. But we'll leave it that way. So we've got a NavMesh agent on this soccer player. And then if we go up to window, I'm going to try to find one of these windows that is normally not in the default view. But if you go down to AI and go to navigation, that's the one I want. So with navigation, this is going to allow us to create what's called a nav mesh. A navigational mesh is going to be kind of the boundaries for where an AI agent is allowed to go, where they know they can go. And so I'm going to choose the, let's see, I need to choose in the object tab here, I want to select the plane. The plane is the surface where I'm going to be creating a navigation mesh. So I'm going to select navigation static, saying that this object, this plane object, is going to stay still. It's not going to be moving. And the navigation area that I'm creating is going to be walkable. This is telling it that the AI is allowed to walk here. Then when I go to bake, there's some parameters I can mess with, but I'll just press bake down at the bottom and let it do its work. So you can kind of see it if you look at the edges. It has decided, all right, based on these parameters, the AI is not allowed to these edges, but all of this blue area is the nav mesh. And if you create nav mesh obstacles, different things, static objects in here, let me see. Let me see if I can create one. Oh, actually the wall is one I can use. So right now they will try to run through the wall, but I can select that as not walkable. Yeah. So once I bake that as a static a navigation static object, you can see that it recognizes that as something that the AI should try to stay away from or not be allowed to just walk right through. So when it tries to map out a path to get from point A to point B, it will have to go around that wall. All right, so we've got that. We've generated a nav mesh. So I'll go back to the inspector panel, back to normal world where we don't have to deal with the navigation mesh. And now we have to tell the nav mesh agent where to go. So first, before I jump back into the script, we should assign the ball. The sphere is the ball. I should really call that ball. Okay, so I can grab the ball and drop it onto that reference. Cool. All right. So a couple of things we need to do here. We need to recognize that the NavMesh agent component is the thing that is doing all of the work. Its target is going to be the ball or where the ball is, and that ball might move. So we're going to have to tell it every frame or roughly where the ball is so it can find a new path to get there. So first of all, I'm going to need a reference to the component, the NavMesh agent component. So if I start creating a reference out here, let's say private NavMesh, it doesn't show up because NavMesh agent is in a specific part of the Unity engine. So here I'll need using Unity engine.ai. And then I should be able to find NavMesh agent. I'll just call it agent, that's fine. But remember, this is just a reference. This isn't filled in with anything. It's effectively null right now. When we start up the game, this is when this soccer player can get a reference to its own nav mesh agent using the get component function. All right, and so we do this once right up front at the beginning of all of this because we don't have to do it later. It's just more work for the engine to look up that nav mesh agent component every single time. So let's do it once at the start. And as long as we're not changing that agent, it's totally fine. Saves some computation. All right, so then we've got our agent dot set destination. So it takes a vector3, a position, as a target. So ball dot transform dot position. All right. So the soccer player is all set. We're just getting the nav mesh agent component, telling it where to go, and doing that every single frame. The ball may move, but that will be updated in its position here. Okay, there he goes. Oh. All right, he did not collide with the ball. This may be an issue. I'm not certain why he's doing that. The ball on the default layer. I don't know. I'm not sure. He's pushing me around.
I don't think he gave
Is
the
the-
rigid body.
I didn't give him a rigid body. I was hoping that it wouldn't matter. Because rigid bodies and the AI system don't play well together. Well, I guess we gotta do it.
Wait, what, does it have a cooldown that doesn't play?
Yeah.
Now it's gonna follow.
Yeah, probably. If I bump into it, it definitely will. Okay, so yeah, it's a very weak soccer player, but see, this is the issue. The AI is driving it toward the ball, but the physics engine is carrying it with its velocity in the other direction. So it's really kind of annoying. I'm just gonna throw something in here just so we can move on, but don't do this normally. I just really hate how the AI system does not work well with physics. But whatever. Yeah, I'm just gonna deal with it. Okay. But anyway, like I said, you probably shouldn't be get componenting every frame if you can avoid it, but I just want it done. All right, so that's going to set its velocity to 0, and the AI system doesn't really obey the velocity anyway, so there it is. Okay, no, toward the goal, to the goal. Okay, good. All right, cool. All right, so that's the AI system, and if you can, of course, at runtime change what the target is, or you can change the speed of the guy using his properties here. But it looks like we don't have a whole lot of time left. So we'll go talk about the UI system, hook up a couple of UI elements, and then call it a day, I guess. Sound good? All right. So let's dive into this. Oh boy, whole world of UI. So if you go into your hierarchy, right-click in here and go to UI. You're given all the options that we have. I'm going to make a panel first. And you'll see something really weird. So what Unity does is it superimposes these two coordinate systems. We have our 3D coordinate system down here, where 1 unit equals 1 meter. And way out here, this is the two-dimensional coordinate system, where 1 unit means 1 pixel. So when you put them on top of each other, your UI looks pretty out of place. But if you go up to the top of the scene view, there's a 2D button that switches you over into that view. And I can double click on the panel to kind of focus it. So I can just ignore the rest of my stuff going on down there while I work on my UI. You'll see on the left, it has created the panel object, but it's also put it nested under a canvas. And so the canvas is kind of the controller for all the UI stuff that happens under it. So you can treat panels as kind of like windows or sub-windows. And I'm going to take my panel and make sure that you're using the rect tool. The rect tool is the general purpose tool for messing with UI objects. And I'm going to just resize this panel. Let me put it over here, maybe in the middle. That seems pretty good. So this should work fine. I should be able to play, and I should see that UI panel right at the top there. Yep. And I can mess with the properties. Here, there's a color selector, so I could change it so that it's fully opaque if I wanted to, and fully red because I want it to be. And that should work for us. Yep. And then I can put some other stuff in that panel if I want to. You can put stuff outside of panels, totally fine. You can have text just floating around on the screen, but I'm putting it in front of a panel so that's easier to see. If I go to right-click on the panel, go to UI, and then choose one of these text things. The Text Mesh Pro is the one you're supposed to use, so I'm going to use that. And since this is the first time using it, it asked me to import some things. I'll go ahead and let it do that. All right. So Text Mesh Pro used to be a third-party plugin for text, but it did a better job than the built-in Unity text. So Unity bought them out and absorbed it into the editor. All right, so with our text, we can now type whatever we want here for our text input. You know, if I want this to say score. And then I want it to maybe be only over here. And it's kind of getting crunched up here and not resizing. So I can mess with the font size, or I can choose auto size to make it fit into that spot. And maybe some other auto stuff like aligning vertically to the center. That looks pretty good. Left aligned. Yeah, that's good. I'll make another text object. This one is going to be the actual score, the number. And I can put it over here. All right, let's do 0 for now. Auto size. Center it. That seems great. Okay, so we've got a little score panel. We're going to have to hook this up in some way. And what's typical is that you create an object that's in charge of managing game state like this. But I think we are kind of too low on time to really do it the right way. So I'll do it the wrong way. How's that sound? But yeah, normally you would make an object that doesn't get destroyed when you load new scenes, so that you can have a score stored in that object and it will persist through loading different scenes, which is another thing that we haven't talked about. But if you have questions about any of this stuff, about other things we haven't touched, reach out to me. You can reach out through your professor, however you want to do it, and I can give you some tips. But yeah, let's get our ball, I think had, oh no, it was our goal, right? Our goal zone had a script. So this goal controller, we're going to tell it to update the text. We need access to the Text Mesh Pro features, so using TM Pro. And then we will need a reference to a Text Mesh Pro UGUI object that's going to be our text, our score text. And when we trigger a goal, here we go. We're going to actually tell the player about this. We'll do score text dot text equals, and then we're going to have to decide what kind of a string we're going to be putting there. So we'll probably have to have some sort of score. Let's start it at 0. And then the score text can be set to score.toString. That seems pretty good. We also want to increase our score. Okay, that would make sense. Increase our score and then update the text to say what the new score is. All right, let's head back over to the editor, hook this stuff up, make sure it works, and then I guess that's all we got. All right, so our goal zone now is responsible for knowing where the score text is. So I believe it was this one. If I had named them correctly, then I would know. Goal zone. Grab the text, drop it in there. Okay, I'll let him go score. Go. You can do it. I'll give you a push. Get to the goal. Ah, yeah. All right. Score. We did it. Okay, so some other things that we did not cover that are useful here. There are buttons you can put in the UI. So if you say make a title screen, you should have a button that lets you play the game. And so hooking up the button to the action that it actually does, which should be switching to a new scene. You have a separate scene that is your title screen. Click the button and it should load a new scene, the soccer game scene. So that's a big one. And the using a single object to persist and save the score between scenes is another one that we did not get a chance to do. Plenty of other cool stuff. Real quick, like particle systems, we didn't talk about that. But if you go into the create menu and you create a particle system through that menu, just play around with it. It's a ton of fun. Another one, a really important one for games, is raycasting. Raycasting is like shooting in an invisible line through the world and seeing what it hits. And so we didn't do that, but you interact with it through the physics engine, and it can hit colliders along its path. So you can do this to implement things like hit scan if you're doing a game where you're shooting at stuff. Sometimes you don't always have a projectile, but you'd rather just, like, I'm pointing at a thing, hit it. Another thing you can use that for is like enemy visibility. Like if there's an enemy wandering around and you're hiding from it, it could try to do a raycast from it to you, and if it hits you, it knows that it sees you, and then it can be like, ah, I'm coming right after you, and it can, or maybe you lose the game or whatever. All right, so yeah, any last questions before we're done here? Okay. So I'll push this stuff to my repository. I'll send the link to your instructor, and I will publish this recording somewhere, and you'll have it for reference. Hope you guys enjoyed our time together, and come check out the Inkwell Studio sometime downstairs in Robert Frost. It is a cool place, and have a great day, everyone.
Thank you.
So, right now,